from group Byte Me. So today we are going to explain about cipher blockchaining or CBC. So for the implementation, the encryption process, the plain text will be divided, as can be seen in this illustration. The plain text will be divided into n-bit size blocks. So in this plain text one, so the first block of the plain text will be XOR or exclusive OR and n-bit number of initialization vector or IV. So the initialization vector can be either a random number or a pseudo-random number. And then after the XOR, it will be put into the encryption process to be encrypted with a key. And then it will be outputting the ciphertext. So for the second stage or the second block of the plain text, the plain text will be XOR, not with the initialization vector, but the output of the first block of ciphertext, and then it will be put into the same encryption process with the same key, and then it output the second ciphertext. The process will continue until all of the block of plain text are encrypted. So for the decryption process, the step it has is the same but in reverse. So like this example, the ciphertext one will be we put into the decryption process with the key that is used before, and then it will output the ciphertext. The first the first plain text, and then it will be XOR with the initialization vector from the same one used in the encryption process. So and then it will truly output the true plain text. For the second stage of the decryption process, so the second block of the ciphertext will be also put into the decryption process with the same key, and then it will be XOR, not with the initialization vector, but the first block of ciphertext, and then it will output the second block of plain text. And also same as the encryption process, this decryption process will continue using the same step as before until all of the block is decrypted.
Okay, so next I'm going to tell you where does CBC is suitable to use to. So CBC is suitable to use in block cipher because CBC is an operation for block cipher to encrypt a sequence of bits as a single unit or block with a cipher key applied to the entire block. It takes the plain text block by block, so it's not a stream cipher because it's more complicated.
The advantage of cipher blockchaining or CBC in terms of identical plain text, randomized encryption, repeated text mapped to different encrypted data, which means even though the plain text here for plain text 1 and plain text 2, even though they have the same value, the outcome of the ciphertext here and here will be different because it depends on the IV. So for plain text 1, the IV will be a random number that is chosen by the user. But for plain text 2, the IV depends on the outcome of the ciphertext 1 here. So it shows that these two will be different outcome even though the value for plain text 1 and plain text 2 is the same. So in terms of efficiency, proven to be secure based on the block cipher has desirable properties and that random IVs are used. So here it shows that IV it is secure because for each plaintext it requires different IV. Like I just explained, IV for here is the random number that user choose, and for plaintext 2 is the outcome of the ciphertext here, and so it shows that each IV for plaintext 1, plaintext 2, and so on will be different. So that shows that it is proven to be secure.
For this advantage of CBC in terms of chaining dependencies, ciphertext block depends on all preceding plaintext blocks. The chaining mechanism causes ciphertext CJ to depend on CJ minus 1 and plaintext MJ. So, enciphering is not independent of the reordering. So the reorder will affect the decryption. The second one is error propagation. Errors in one block will propagate to two blocks. An error in the ciphertext block Cj will affect the decipherment of Cj and Cj plus 1. So one bit error in ciphertext Cj will affect all bits in plaintext Mj and one bit in Mj plus 1.